Assalamu alaikum wa rahmatullah and good afternoon to all of you, our beloved viewers. And as I said yesterday, not our listeners, but rather our viewers to VOC Facebook as well as VOC's YouTube channel. My name is Amir Adams and I am a presenter at the Voice of the Cape. And Alhamdulillah, each and every year at this time, when the matriculants are preparing for their trial examinations, or as we would say locally, their mock exams, and of course, they are after preparing for their NSC exams, we have these sessions where we have people who come together who are professional tutors who basically are there to give over discourse and reminders to you, our beloved matriculants out there in the community, in order for you to effectively prepare for your trial examinations as well as your NSC examinations. Alhamdulillah. Today we are honored to be joined with Brother Imaad Isaacs, who is an educator at Futures Academy, which is South Africa's online high school, and he will today be going into the topic of algebra and in particular be touching on mathematics paper 1. I hope that all of you, our beloved matriculants, will benefit greatly from his discourse, and please forward and share this link with all of your family members as well as friends who are in matric will be able to benefit from this discourse today and this presentation by Brother Imaad Isaacs, who is an educator at Futures Academy and will today be going through content for mathematics, grade 12, in particular, mathematics, paper 1, and a section deals with algebra. Without further ado, Brother Imaad, Bismillah.
Okay, shukran Amir. Thank you very much. Assalamu alaikum wa rahmatullah. Good afternoon or almost good evening to our viewers on Voice of the Cape's Matric Revision program. I'm very honored to be here on behalf of Futures Academy to be joining the Voice of the Cape as we prepare and assist our matriculants in the preparation for the final examinations, particularly on the subject of mathematics. For myself, this is, of course, very exciting. Our own students know I don't really get much time to actually teach in the school. I'm a bit more involved in the administration. And so these opportunities are always valued. Okay, so today we're going to be looking at the section on algebra. As many matriculants would know that algebra is not a new section in grade 12. It does make up a significant portion of the paper 1 examination. And that is why we're also focusing particularly on the collectible marks. Now, when you get to grade 12 and you start looking at mathematics, and you look at the structure of what curriculum content is covered, one will know that there's significant portions of grade 10 and grade 11 work that is tested particularly in the algebra section, okay? So there's no real new algebra that learners are taught during the matric year. However, it is essential that they actually learn the content in the algebra section because all of that work is collectible marks. Those are giveaway marks coming from grade 10 and grade 11 and even from previous years. Okay, let's go into this fairly quickly. If we look at the examination breakdown, what we see is that there are 6 topics that are tested in paper 1, and that's algebra, number patterns, finance, functions, calculus, and then probability. Now, the section on algebra makes up approximately 16 to 17% of the examination, and that's looking at 25 to approximately 28 marks, give or take, right? Give or take 3 marks. In every one of the 2 papers, paper 1 or paper 2, it is possible that bookwork can also be tested. So what is bookwork? Bookwork is known as the proofs, okay? And that's like the formal theoretical proofs of how certain formulae and how certain theorems are derived. So in paper 1, it's a maximum of 6 marks, and in paper 2, it's a maximum of 12 marks. So definitely the bookwork sections, because it's just regurgitation of a specific proof, is also to be considered collectible marks, okay? I think for the future sessions, we have about 10 or 11 weeks with the VOC going through the content. We're going to set up a page on our website that allows you to download the content for the relevant sessions that we have online, inshallah. And I think from basically it will be up in advance coming from the following week. So definitely bookwork and proofs and theorems, that's something that must be studied because it's also giveaway marks, collectible marks. Okay. Right, number patterns, also one of those sections where a lot of the work has been covered in the previous grades, and then in grade 12, obviously, they've gone to do it a little bit more with a formula and adding summations. Functions has largely been touched in the previous grades, as well as your probability and your finance. So very much the grade 12 content is building on grade 11, and there's a lot of collectible marks coming from the previous year's works that must be solidified. Okay. Then we must also briefly talk about what is the cognitive distribution of questions in the examinations. Okay. So every question that is in a mathematics paper is ranked between level 1 to level 4. Level 1 questions are known as knowledge questions. Level 2 questions are known as routine procedure questions. Level 3 questions are known as complex procedures, and level 4 is known as problem solving. Now, just in terms of breaking this up, it's important for every child to know that knowledge and routine procedures make up the bulk of your papers. Okay. Knowledge questions are 20% of the paper. Routine procedures are 35% of the paper. Now, cognitive levels, it's not necessarily difficulty levels, right? Those are two separate things that we look at when we grade a paper. When we grade a paper in terms of the ranking per question, we look at the cognitive level, and we also look at the difficulty grading. So difficulty could be easy, medium, or difficult. And knowledge up to problem solving looks at what type of brain function is involved there. Okay. So if we think of knowledge questions, these are example straight recall questions, right? Domain and range, for example, certain theorems, the exterior angle of a triangle is equal to the sum of the opposite two interior angles. That's also examples of straight recall knowledge theorems. And then as you progress through the grades, for example, a certain routine procedure at grade 9 level, let's say we take calculating or determining the equation of a straight line. If we were to take such a question, when we determine the equation of a straight line, it's y equals mx plus c. The y is the dependent variable, the x is the independent variable. We need m is the gradient, and c is the y-intercept, right? So at grade 9 level, that is potentially a routine procedure, even at grade 10 level, because you need to, potentially a complex procedure. So why do I say potentially a complex procedure? Because it's made up of two routine procedures. The one routine is you need to find the gradient. So y2 minus y1 over x2 minus x1, right? And then you need to substitute in a point and find the y-intercept. So in grade 9, determining the equation of a straight line is potentially ranked as a complex procedure. And why do I say that? Complex procedures are generally a combination of two or more routine procedures put together, okay? However, that same question, when you have to determine the equation of a straight line, given certain things and certain information, that is most definitely a routine procedure at the grade 10 or grade 11 and grade 12 level, okay? So routine procedures are generally questions you've seen in class, you've seen them in your textbooks. Sometimes they involve two or more steps and so forth. And complex procedures are generally these two or more routine procedures put together. And as you go through the grades, remember that a complex procedure might become a routine at a higher level, and a routine procedure can become a knowledge question as you progress. Okay. Now, what is a problem-solving question? Now, as the description over here says, it's a non-routine exercise that require the ability to break down the question into smaller parts or sections, may or may not be difficult. Okay. Now, how I would describe a problem-solving question is it's generally familiar concepts in unfamiliar contexts, okay? And realistically speaking, there's very few questions that truly rank as problem-solving questions, right? Don't think of a problem-solving question as one that must have word sums. It's not meant to be necessarily a verbal question involving words. It's where you could have a series of routine procedures put together, but they give you a question that involves a rocket ship, and then now you need to make the connection that's actually relating to certain concepts, maybe from calculus or from here or there, etc., etc. Okay. So generally, the problem-solving questions, that's the one thing. It could be familiar concepts in unfamiliar contexts. And number two, we also would potentially describe it as a question that our 99% student and 100% student, the kid who's getting those marks, does really need to stop and think and actually problem solve. That's a problem solving question. Okay. Now there's something that we also want to make available on the site. I'm going to bring it up over here. This is some of our colleagues in the maths department have put together a tick list, right, or checklist, if you may. And what we've done, and what the colleagues have done is we've analyzed the matric examination paper and broken it down into various things that you need to know. Okay, this checklist is a little bit on the long side because it's 12 pages long, but it's taking every section. So if we talk about algebra, what are the essential things that you must know for the matric exam coming from algebra? And if there are grade 10s and 11s watching this, this is also critical for you, because the way we've color coded it here, everything that was in yellow is coming from grade 10 and under. Okay, then what is in blue is grade 12 work. Then if you go to level 2, we can see these green things over here. That's grade 11. This part over here is grade 12. That's grade 10. That's grade 11, right? So these are important skills. But now we've also ranked it. And we've said, if you look at algebra, the skill is level 1. I know how to identify number sets. Now, although this is work from grade 10 and under, I must also stress the fact that these are not things that are tested explicitly. In other words, they're not going to tell you, here's -2, and tell us whether it's an integer or tell us whether it is a whole number, or rational number, etc. Right? But there may be questions that when you end the question, the only valid solution is the integer solution or the whole number solution. And that is how number sets is being tested, right, against the context. It's also level 1 skill, meaning a knowledge skill to round numbers to an appropriate degree of accuracy. This is critically important because every year students lose marks. So if the answer was 0.36 and you wrote 0.35 because you didn't round off appropriately, then you also lose 2/3 of 1 percentage point, okay, in the examination. And that's 0.67%. That's a lot to lose, okay? Again, at grade 12 level, factorizing common factors and simple difference of squares are considered level 1 algebra questions. Okay, so I'm not going to, of course, go through the entire tick list and checklist with you, but I do want to say the following. We've mentioned here that if you're only working to pass mathematics, you need to focus only on level 1 and 2. I think we can change the terminology a little bit here. You need to focus on mastering level 1 and 2 and still gain exposure to level 3 questions, right? Which is the complex procedures. But if you're working to get more than 50% in examination, you will have to be competent in level 1 and 2 and then only focus on level 3. At this stage of the year, it is not practical to ignore level 3, but foundationally in every topic, it's important to go through this. So we'll make the tick list available. We'll post it on the VSC pages, and you tick off what you know, what you don't know. And this will also help and assist you to determine what you don't know, because that's also a huge problem. Many students don't know what they don't know, right? And that's also quite important in order to navigate. Anyway, so you'll get the tick list and you can go through it across all the various levels of what needs to be known in every section per topic. Okay. Now, we haven't included in the tick list problem-solving questions because, again, we said here it's routine and complex procedures, generally in unfamiliar contexts. So we can't really rank it because those questions need to be original. They need to be fairly unique. Okay, let's move on. In terms of algebra essentials and collectible marks, things that our learners must know. They need to know how to solve for X because every matric examination paper opens up with an algebra question, roughly 18 to 20, 1 or 2 questions, but in total, the section weighs 25 to 28 marks, okay? That's about 17%. Now, you need to know how to solve for X by factoring using the quadratic formula. You also need to master inequalities. Every single year, something as simple as inequalities, learners are still making errors in it. Master it now, okay? Surds, those are quadratic equations or equations leading to quadratic equations that involve surds. We need to talk briefly a little bit about number sense and domains, and then also mention a few things about simultaneous equations. Okay. Now, A general strategy when we are dealing with quadratic equations, we need to look at two things here. Firstly, we all know, hopefully, what an equation is, right? An equation is made up of some coefficients, variables, but most importantly, it has an equal to sign. With an equation, we can solve, right? With an expression is divided by terms, by numeric operations and so forth. There's no equal to sign. And at best, what we do with an expression is that we will simplify. We will work towards making it as simple to as least the least number of terms as possible. Okay, now two things. Whenever you get a solve for x question, we don't want to work with surds, number one, and we don't want to work with fractions. Those are the two things that we want to ensure we don't have. So those things is, if we don't want fractions and we have a fraction, we must eliminate the fraction. How do we eliminate it? We ensure that we use the lowest common multiple, right? Or the LCD. Okay. If we have a surd, remember what is a surd? A surd is a root, a square root, for example. And if we have a surd, then we want to eliminate or remove the surd. And we do that using two steps. Number one, isolating the surd, and then squaring both sides. And we'll look at examples of that shortly as well. Okay, right. And then lastly, once you've actually gotten rid of those fractions and removed the surds, you must then write the equation in standard form. And what is standard form for a quadratic? We'll write it down here. The standard form for a quadratic is ax squared plus bx plus c is equal to 0. Okay, that's the standard form. If you have a square root, remember there are two steps to the square root. It's going to be isolate the root, meaning have it on one side of your equal to sign, and then square both sides. Okay, right. Completing the square is generally a grade 11 topic. It's taught in grade 11 or even grade 10 at some schools, but it's only required if instructed to do so. Now, having said that it's grade 11 topics and it's not common in the NEC exams, it is still fair game, meaning it can be tested because it's part of the examination guidelines and the CAPS document. And lastly, also know the nature of roots, which we'll talk about a little bit later. Okay, we'll come to number sense shortly. Let's talk about some quick common errors. We spoke about this earlier. Rounding off is a level 1 question. Okay, rounding off, it's not really a level 1 question because they don't ask you to do it explicitly. But the point here is, if you round off incorrectly, this is an example where there was 2 marks, right? 1 mark here and 1 mark over here. Now, 1 mark out of 150 is 2/3 of a percentage. That's 0.6666 recurring percent. This student rounds off to 0.90 instead of 0.91. They lose 0.67%. You need to be a little bit of a merchant now. You need to count every percent and every mark counts, right? So you have to count it. You have to make sure that you don't make silly errors like this. Okay, these are mastery errors. Okay, simultaneous equations. Now, you should all know by now at this stage what a simultaneous equation is. It's an equation. The simultaneous equation questions that you get will ask you to solve for x in a system of equations. With that system of equations, you will solve maybe for x first, or you'll solve for y first. But once you have a result, it is critical that you take that result and you substitute it into one of the 2 equations to find the corresponding x or the corresponding y value. What happens is simultaneous equations are perhaps 6 marks, and then learners, or could even be as much as 8 marks if it's a complex one, they will get majority of the marks, but they will lose 2 marks for the back substitution for the corresponding values, okay, because they forgot to back substitute. Okay, and then another common error that we see in the examinations from some students is when they are squaring both sides of an equation to eliminate the square root. Now, here's an equation. There is a root or a surd where it says root of x plus 7 is equal to x plus 2. Okay, remember when you're squaring both sides, you need to take the entire expression on the other side and square it, okay? Which means that it's x plus 2, everything squared. And of course, you will then expand this FOIL or whatever you use, or just squaring a binomial method. Okay, what students commonly sometimes do is they'll square all the terms that are found on the other side, and they'll write x squared plus 4. Please note, common error, avoid it. Okay. Another common error in this section is learners fail to standardize the quadratic equations when solving for x. So for example, they see this is the first term, 3x squared. They see minus 7 as the second term, so they say b is minus 7. And they see minus 5x as the third term, and they say that is c. That is not correct, because you must put the equation in standard form first, which is ax squared plus bx plus c. And in that standard form, you then read off the values. The coefficient of x squared is your a. The coefficient, or the number in front of x, is your b. And then, of course, the constant term, or any other constants that are there that are summed up together, will be your c. Okay. Right. And then the last thing that I just want to touch on in terms of common errors is solving inequalities. Learners often forget to exchange or to flip the inequality sign when they multiply or when they divide by a negative number. So here's an example. Minus 3x is greater than 10. And to get rid of the 3, they will then divide by minus 3. So on the other side, I'll have minus 10 over 3. Okay, or 10 over negative 3. So the division has happened correctly. However, when I divide by a negative or multiply by a negative, I must flip the inequality. So minus 3x is greater than 10 becomes divide by the negative 3. I get negative 10 over 3, but the inequality sign must flip. These are essentials that we covered in the grade 10 number sense work. Okay, so the reality is every single learner who has adequately prepared by going through the content in terms of routine and knowledge questions in their classroom, done sufficient homework, is supposed to at least score those marks, meaning 55% in the examination. Okay, it means it's possible because there's no surprises in our routine and our knowledge questions. Okay. Okay, before we go to inequalities, now I can pull up my whiteboard because we've blabbered on quite a bit on a number of things there. I'm going to come to number sense also in a bit, but let's go into some simple questions just as a warm-up, right? Just as a warm-up. Let's see. Righto, so remember our quadratic strategy, and I hope you took note earlier. We don't want fractions and we don't want surds. So if there's none of that, remember you move straight to standard form and then you try to solve the question using the factorization or the quadratic formula. So simple questions very quickly. Our favorite, x squared minus 3x is equal to 4. So that is a quadratic equation, but not in standard form, right? So however, we put it in standard form, we have no fractions and we have no surds, so we can go straight to standard form. So the standard form is x squared minus 3x minus 4 is equal to 0. And at this point, we can clearly see that, well, let me try and factorize first. So don't just run into the formula. And for these types of questions, I do want students, even at this stage, we've got about 60, 70 days left to the examination, it's still possible to master these basics, okay? Don't only go to the formula. Make sure you can still factorize at this stage because so many students are reliant on the formula. You still have 60, 70 days to master a number of those basic concepts. Okay, so this, if we read this mathematically, we'll say it's factors of 4 that I need to, sorry, what is the pen and what is the, okay, factors of 4 that I need to subtract, right? Factors of 4 that I subtract to give me 3. And so what are the factors of 4? Of course, you know that. That's 4 and 1. Okay. X and X goes in there. And this here also indicates that the signs are going to be different. And the larger number is going to take the sign of the middle term, which is minus. And this is going to be plus. Okay. I've still got equal to 0 on this side. Now, another critical mistake that learners often make, and generally during the year when we are marking, we're not talking about end of the year, but during the year, if a learner leaves this out, is equal to 0, right? Then the next part of the question, where students often say x is equal to -1 or x is equal to +4. This part of the question, x is equal to 4, x equals -1. You cannot come to this conclusion if you don't have this equal to 0, okay? If this equal to 0 is not here, then I will consider this part of the solution to be incorrect because it's based on a false premise. And where does this come from? At some point in your life, you learned about a dot b, or a times b is equal to 0. It's known as the zero product property, which is a times b is equal to 0 if and only if, right? If and only if a is equal to 0 or b is equal to 0. Okay, so what does this mean? What is a and what is b? We consider a and b to be factors because we're saying a times b is equal to 0. Okay, I'm not 100% sure if we get any messages on the chat from the live streaming, if it shows up in the studio side here, but if it does, just let us know if there's any questions or if we're going too fast or anything of the like. Okay, so again here, this is my a and this is my b. And this thing over here is coming from the fact that x plus 1 is equal to 0. Therefore, x is equal to -1. Because we're asking what must I add to 1 to give me 0? And the answer is I must add -1. Similarly, on the other side, that's actually x minus 4 is equal to 0. Therefore, x, and this is an OR, x is equal to +4 coming from the zero product property. Okay. So again, basic trinomial factorization is a must. Factors of the last term that I either add or subtract depending on what the symbol is to give me the middle term. Here it was factors of 4 that I must subtract to give me 3. Okay, if this was a plus, then we read it as factors of 4, I must add to give me 3. And then we say, well, there aren't any factors of 4 that I add to give me 3. Hence, I may have to use the quadratic equation. Okay. Now, the golden rule when it comes to factorization is always, 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 always check for a common factor. Okay, so the other one was fairly straightforward, but no matter wherever you see something that you potentially have to simplify, even if you're going to look at solving general solutions and trigonometric ratios later on, then we say you must always, always, once again, check for a common factor. Okay. So if one has to solve this over here, remember I can't immediately say x is equal to something and x is equal to something else. I must always work towards a standard form. Now, in standard form, I must I could argue this is in standard form because a's value is 1, b's value is -3, c's value is 0, and I could use a formula over here and I could substitute and I'll get exactly the same answer. However, if I look at this, x squared, right, minus 3x. I try and factorize before I try and use the formula. So I can see here is a common factor. And the common factor in this question is x. Because if I take x times x, I get x squared. If I take x times -3, then I get -3x. Okay, is equal to 0. Okay, now once again, I can see that this is factorized. So that's my first factor and that's my second factor. And I can conclude a solution that x over here, this entire factor is equal to 0, or x is equal to 3. Okay? Now, before we go to the next question, we want to briefly talk about some number sense. Okay? And number sense is very, very important because you're going to deal with things related to domains as well. Let's talk about number sense. If I ask you the question, root of 9, the square root of 9. What is the answer? I don't know if Imaad is there. If Imaad is there, you can maybe help me out. If there's anybody watching live, feel free to send us a solution. If there's students in any of our student groups, feel free to send us a solution as well. Okay, so I see some people are saying that the answer to the square root of 9 is 3. And others, is there any takers? Someone's mentioning possibly -3. Okay, are there anybody that says -3 and +3 are both potential solutions to the square root of 9? Okay, right. Okay, so now when we talk about number sense, and we're going through number sense over here, The root of any number in the real number system is defined as strictly positive, right? Or zero, sorry, not strictly positive, but positive or zero, okay? Which means it's greater than or equal to zero. So hence, if a student asks you, if we have a student asking the question, what is the square root of 9, if somebody asks, then the answer is only 3, okay? The square root of 9 is not equal to -3. It's not equal to -3, okay? For the sake of time, we won't go into too much of this, but we will just indicate the definition of any root is always positive or 0, which means that the number under this root must be 0 or must be greater than 0, okay? And this is going to become very, very important when we start speaking about domains in this session as well. Okay, so square root of 9 is only equal to 3. However, we come to this question now. If I get x squared is equal to 9, what's the answer? Well, students will generally say, well, the answer over here is actually x is equal to plus minus the root of 9. Okay, it's equal to plus minus the square root of 9. Now, if it's equal to plus minus the root of 9, then therefore x is equal to either -3 or x is equal to +3. It's one of the two, right? -3 or +3. Now, the question is, where's this coming from? What's actually happening over here? What's actually happening? Okay, so this whole thing here, firstly, I want you to notice two things. Number one is that the plus and the minus sign is in front of the square root of 9, which means it's going to be plus or minus that invisible 1 multiplied by the square root of 9. And the value of the square root of 9 is actually 3. Okay? Then, that's the one part. The second part is I want you to note that that thing over there is actually a shortcut, right, for solving this question. And remember, our strategy with solving this question is we always work towards standard form. Now, when we are working towards standard form's agenda is to get the expression equal to 0. So in other words, an equation where we have equal to 0 on one of the sides. So if I look at x squared minus 9 equal to 0, right? I'm not a big fan of writing it like this, but I want students to know that they can do so, but they must remember that that is a shortcut. Okay. And we can revisit the previous question as well. So x squared minus 9, x squared minus 9. Now when we look at it, we say, well, x squared minus 9 is actually a difference of squares. And that means when I factorize, I go x minus 3, and I go x plus 3 is equal to 0. Now that that is equal to 0, I can now clearly say x is equal to 3 or x is equal to -3, because now that's my products. And you apply the zero product property that we just learned previously, and I can solve, okay? So hence, this thing here of taking the square root and remembering to have the plus and the minus in front is actually a shortcut for doing a longer version of difference between two squares. Let's just revisit the previous question for a moment. When we look at this question, this one here, this x squared minus 3x. Another common thing, let's say the question was written as x squared is equal to 3x, okay? These two things are equivalent, okay? Now, sometimes students are also quick to solve. And what they do is they might divide by x. And when they divide by x, they say, hey, that's great. That's 1. Therefore, x is equal to 3. So my advice to you in solving quadratics is work towards, number one, work towards standard form, meaning working towards something equal to 0. The problem with this solution over here, okay, it has solved one of the solutions, number one, okay? However, it's a bit more complex than that because we need to introduce a restriction since we've introduced x in the denominator, but let's forget that for a moment. when they divide like this without looking for the common factor and working towards a standard form of equal to 0, you've lost one of the solutions. Can you see? The solution is missing, and hence the question will not be completely answered. Okay, right. So for our guys online, give us a thumbs up or just let us know that you're still following and that we are good on this side. Okay, right. Let's do at least one quick question with a quadratic formula. I think we can. I'm not sure how we're doing for time there, Brother Amir, but let us look at something quickly. We'll do two things. We'll do two things here. Number one, 2x squared minus 3x is equal to 4. 2x squared minus 3x is equal to 4. Okay? Remember, the objective is always to write in standard form first, but we're checking for a fraction. We see no fractions. Great, excellent. We're checking for a square root. We see no square roots. So let's move. We can now go work towards standard form. So 2x squared minus 3x minus 4 is equal to 0, right? Definitely in standard form. Now, when we look for factors, we can actually take a times c, which is 8. 2 times 4 is 8. And we say, well, what factors of 8 can I subtract to give me 3? And realistically, the factors of 8 are 1 and 8, 2 and 4, and then 3 and nothing, and then 4 repeats, and so you've covered all the factors. So clearly, there's no set of factors that when I subtract them for 8, because I took 2 times 4, will actually give me 3. So two ways to recognize this. Number one, in the question, it will either say to 2 decimal places. It will tell you round off to 2 decimal places. Then you know, actually, I need to use a quadratic formula there. Alternatively, you could have done what we've just done if they didn't give you this, and you saw that it cannot factorize. Hence, you must use the quadratic formula when it cannot factorize. Okay, so what's the quadratic formula? By now, application of the quadratic formula is also fairly simple. It's minus b plus minus the square root of the discriminant, which is known as delta, and that's going to be b squared minus 4ac, okay, divided by 2a, okay? Now remember what your substitutions are. This is your a value, that's your b value, that's your c value, and so minus 3 plus or minus the square root of 3 squared, which is 9. So however you do it, you can either substitute in everything. You can write down 9. That's going to be 2. This is going to be negative 4. Okay. All divided by 2 multiplied by 2. Okay. At this point, you all are well aware that the plus minus sign is 2 equations. So you need to solve this with minus 3 plus whatever delta is, root of delta divided by this, and minus that as well. Okay. So, sorry, just see who's this. Okay. Now, let us quickly just grab a calculator. I had to run around like crazy just before this to look for a calculator, and luckily found something here in the office. So that's going to be the square, some fraction. Type it in on your calculators over there. Okay, so this calculator's buttons are all worn out, and I'm not exactly sure where everything is because we don't use these things. But let's try. Let's see if we can see where's everything. Plus the square root of 9 minus 4. Oh man. All over 4, 2 times 2, right? That's 3 plus root 41 over 4, which is 2,350, which if we round off, x is equal to 2,35, or x is equal to, let's do the negative quickly, negative 0,850, so it's negative 0,85. Okay, the next question that I want to do, remember you can always come back to this recording. The next question that we want to look at quickly is something that may potentially require the quadratic equation, Alternatively, we can look at things a little bit differently, right? So let's say I have 2, because I'm just looking at the question now, 2x squared is equal to 4. Now remember, once again, earlier I said, sometimes students divide, so we can divide by 2. That will work. That will actually not spoil anything here because it's an equation, right? When we're dividing by the variable that we have to solve, that's when we introduce some degree of complexity, which makes things a little bit more challenging. However, if we take 2x squared minus 4 is equal to 0, okay, we take 2x squared minus 4 is equal to 0, and remember the golden rule, work towards factorizing. But when we factorize, there's an order preference in how we factorize. Number 1, common factor. Always look for it. Number 2 is then look at your difference of squares and then look for trinomials and so forth, right? Okay. So if we go into this one over here, 2x squared minus 4, there's a common factor of 2. I'm left with x squared minus 2 is equal to 0, because that times that gives me this, and this times this gives me that. Okay. Okay. Now, at this point over here, one option was to do the formula because it doesn't factorize, right? One option was to look at the formula because clearly it doesn't really factorize further. The other option is to look at this, and sometimes students look at this and they say, there's a minus sign, there's 2 terms. And whenever there's 2 terms, there can always be a difference of squares, not necessarily perfect squares. So if I were to factorize this further, I can have 2 into x minus something multiplied by x plus something is equal to 0. Okay? So what are those somethings? What's going to go over here? And what's going to go over there? Whenever you have 2 terms separated by a minus sign, like we have over here, those 2 terms can always be factorized into a difference of squares. And the format for a difference of squares is you take the square root of this first term, and the square root of x squared is just x, and you place it there and there. Okay? Then you have minus and you have plus, and then you take the square root of the next term. So the term that we have over here is going to be square root of 2. That's going to be also square root of 2, because the square root of 2 is square root 2. Okay, and now we can solve. That means that x is equal to root of 2, or x is equal to negative root of 2. Okay, and what's the decimal value of square root of 2? It should be 1,4 something, 1,414. So that is equal to, or approximately equal to 1,41 if rounded off, or x is equal to negative 1,41. Okay, right. So what you can do is you can use the quadratic formula over here for 2x squared minus 4 is equal to 0, with a's value being 2, b's value being 0, and c's value being negative 4. And you can check, if you substitute into the quadratic formula, do you get the same values? Okay. Okay. So right. Excellent progress so far. I hope you've done that. And now if you've done that, once again, that substitution will look as follows. It's going to look like x is equal to, of course, negative b is just negative 0, plus minus the square root of 0 squared, which is just going to be 0. But for full whatever, let's just add the square in there as well, into minus 4 times 2 times minus 4 divided by 2 multiplied by 2 And that's going to give you the same answers that you have over here. Okay, and you can clearly see that. Yeah, it's going to give you 2 comma something, which if you divide gives you that 1 comma 41. Okay. That is okay. Right. Okay. Let us quickly do one inequality, 1 or 2 inequalities that we can. So before we go into an inequality, let us do a very quick number sense question. So if I have x minus 5 all squared plus 3y plus I don't know, 3y plus x squared is equal to 0, right? Now, when you get a question like this, and the question would read, solve for x and y. Okay, so there was a question like this that threw learners off in 2015 in the paper 1. Because generally when you're solving simultaneous equations, we're taking a slight detour from the simultaneous equations routine procedure that you must master, that you must go through because it's repetitive and you will get marks for it, right? Just a slight detour. And we're looking at something where the question is slightly different. X minus 5 all squared plus 3y plus x all squared is equal to 0. Okay. How do we solve a question like this? Because when we get simultaneous equations, we need unknowns, which are your variables, and we need equations to solve them. And as a general rule, for a system of equations to be solvable, we must ensure that we have at least the number of equations equal to the number of variables. So if we look at this question that is given over here, there is one equation, right? But there's 2 unknowns. One equation, and we have 2 unknowns or 2 variables, okay? One equation with 2 unknowns or 2 variables. Now, you need this to be equal to, at least equal to. So that is why generally when you get a question and they give you x and y in the one equation, there's an x and y in the other equation, you need at least 2 equations to be able to solve for x and y simultaneously in that set of equations. If you have less equations than the number of unknowns, then it's not solvable in a system of equations using simultaneous equations, right? Whether by elimination or substitution, etc. However, this question, though, means we can't solve it in that manner. And it was included in the paper and it wasn't a mistake. Okay, so here the solution, though, is to look at number sense. Okay, so there's already one thing that we looked at earlier from number sense. We said that the square root of any number is always strictly, I keep saying strictly positive, please forgive me, it is always greater than or equal to 0. So in other words, the thing under the root is going to be a positive or it's going to be 0, and the entire value of the root with the parameter or the argument thrown in there is going to be greater than or equal to 0. So if the thing under the root is 0, the whole thing becomes 0. If this is a positive number, then the answer will be positive. So that's the first thing we tackled in number sense earlier. Now, we take this back to number sense. And I want you to write this down and make a note, is that x, right? X squared, or anything squared, x plus 2 squared, x plus 5 squared, doesn't matter what it is, cow squared or chicken squared, whatever it is going to be positive or 0, positive or 0, okay? So in other words, anything in a real number system, when we square it, will be greater than or equal to 0. So this question had to be solved by number sense. Now, I've got questions for you. When we take x minus 5, if we square it, right, it's either going to be positive or it's going to be 0. When we take 3y plus x, that whole bracket, and we square it, once again, it's going to be either positive or it's going to be 0. Okay. Now, the question is asking you to determine this thing that is squared plus this thing that is squared what are the values that I can throw in here to make this whole thing equal to 0? Now, when we say it's either 0 or it's positive, it's either 0 or positive, let's take the argument that both brackets are positive. If this is a positive number, right, and this is a positive number, this whole thing, when I square it, is a positive number, not the thing in the bracket, but the square thereof is a positive number. What do you think is going to happen when I add two positive numbers? I get a bigger positive number. Excellent, right? So if I get a bigger positive number, clearly that is not 0, okay? And we can't say this thing is negative and this thing is positive because these are squares of things, and the squares of real numbers or whatever I want to square in the real number system is going to be positive, which means the only way that something squared plus another thing squared will be 0 is if both of those things are 0, okay? If this whole thing is 0 and this whole thing is 0, then I can get a 0 because only 0 plus 0 is going to give me 0. Because if I have a positive plus a positive, or if one bracket is 0 and the other one is positive, then I'm not going to end up with 0. Okay, so we'll conclude on this one. Let us just throw this in over here. The only way this makes sense is if I use number sense, number one. And number two is if I conclude that this bracket x minus 5 is equal to 0, therefore x is equal to 5. Okay, x is equal to 5. Okay. That's the first one. Now I've got the next one, 3y plus x, right, is equal to 0. However, I've solved for x because it's the same x in both, right? It's the same system that we got to work with here. So I'm going to say 3y plus whatever I found over here, which is 5, is equal to 0, because that 5 is now coming from there. Therefore, y will equal to minus 5, I've taken the 5 over, divided by 3. And that's my solutions. Okay, so guys, I think in our next session, we'll probably have, we will be having one chief mathematics education specialist also joining us. And that individual will do some of the higher order questions with you, and I will work a little bit more on these fundamentals as well. And I think we will be including quite a few sessions with the VOC over the next 8 to 10 weeks. I hope that today was valuable and that you have learned something, and hopefully in our session next week, in our session during the coming week, I'll continue with algebra and we'll have a double session next week, inshallah, bi'idhnillahi ta'ala. Over to the studio over there, Brother Amir, inshallah, shukran so much. Honored to have presented today for our opening session in the VOC's Matric revision program in collaboration with Futures Academy.
Indeed, we say shukran, jazakallah khair, and as we say in Cape Town, baitra makasi. Thank you very much to Brother Imaad Isaacs for so beautifully giving over the discourse and giving over the second session that we are running on VOC, and it is of course mathematics for grade 12 and dealing with a section of algebra specifically pertaining to preparation for all the matriculants out there for mathematics paper 1. I just wanted to say that Brother Imaad also asked me to join in and to solve some of those equations there. What was the square root of 9? I knew it. I just wasn't going to answer because I have to remain neutral. We give all the matriculants out there, all of the people joining on the platform, inshallah, to answer those questions. And I hope that everyone have benefited greatly from this. Like I said, please encourage all of your family and friends, all the matriculant students out there to please join into this platform. This will, of course, be on the YouTube page of the VOC as well as on the Facebook page. And as Brother Imaad said, we kindly request everyone, please let us make this sessions go viral. All the matriculant students that are out there, please inform them, and inshallah in the future sessions they will be able to enjoy good content and discourse regarding how they can tackle the subject of algebra for mathematics preparation for paper 1, as well as all of the other subjects that we will be tackling. Once again, we say shukran and thank you very much to Brother Imaad, as well as to all of you, our beloved viewers, for tuning in. Until tomorrow, inshallah, when we take on session 3, we wish you all the very best. Bilawat al-Kla Kabangal, so already Maghrib time. So inshallah, we end off here. Until tomorrow, inshallah, we say to all of you, wassalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam.